Welcome to my YouTube channel. So today I am going to deliver a lecture on phase locked loop, that is PLL, so under the linear integrated circuits. So phase locked loop, we are simply says PLL. So it is one of the fundamental building blocks of linear system. So it is a closed loop system designed to lock the output frequency and the phase to the frequency and the phase of the input signal. So the aim of the PLL is to lock the output frequency and the phase with the input frequency and the phase. So it is available as a single package. So different ICs are there. So IC 560, 561, 562, 564, 565, and 567 are some of the PLL IC. So this phase lock loop technique is used in frequency control, that is in satellite communication system, airborne navigation system, so FM communication system, and also computers. So these are the applications of phase lock loop. So this is the basic block diagram of phase lock loop. So we are giving the input, so frequency Fs, so input voltage Vs to the phase detector. So that output is given to the low pass filter. So low pass filter output given to the error amplifier. So error amplifier signal is given to the VCO, that is voltage control oscillator. So our phase detector is used to compare the input frequency Fs with the output frequency of the VCO, that is voltage controlled oscillator. Output frequency is F0. So phase detector going to compare the F0 and the Fs. So if it is not equal, means it produces some error signal. So that error signal is a DC signal. So that is given to the low pass filter. So in this low pass filter, eliminate the high frequency harmonics. So only low frequency signal only allowed by the low pass filter. So that signal is going to the input of the error amplifier. Error amplifier amplifies this low pass filter output voltage, that produces the control voltage DC. So that control voltage is given to the voltage control oscillator. So finally F0 output will be produced. So if Fs is equal to F0 means this process will be stopped. That is, the phase lock loop will be, that is frequency will be locked. Output frequency is locked with the input frequency. This is the overall operation of the phase lock loop. So phase detector function is to compare the phase and frequency of the incoming signal with the output of the VCO. So if there is difference available means, so error signal is generated. So output of the phase detector. So this error signal is DC voltage. So is given to the low pass filter. So low pass filter. So without output of the low pass filter is without high frequency noise, that is error voltage or control voltage. This voltage is amplified by the error amplifier and is given as input to the VCO. So finally VCO produces the F0 output. So PLL can be operated in 3 different modes. So modes of operation. So one is a free running mode, second one is capture mode, third one is phase lock mode. So free running mode means if the control voltage is equal to 0, that is VC is equal to 0. So VC is equal to 0, then VCO is in free running mode. So and its output frequency is called as the center frequency. In free running mode, the frequency is called as center frequency. So next one is capture mode. So error or control voltages forces the VCO to change its output frequency in the direction that reduces the difference between the input frequency and the output frequency. The capture mode, the error or control voltage forces the voltage control oscillator to capture the output frequency. So this operation is continuous till all the output frequency VCO is equal to input frequency. So the difference between the input and the VCO output will be reduced in the capture mode. Finally, it reaches the Fs is equal to F0. So output will be locked. This is called, so this operation is called capture mode. So this operation will be continued. So when Fs is equal to F0. Third one is phase lock mode. So once the two frequencies are same, the circuit set to be locked. That is Fs is equal to F0 is equal means the frequency is locked. That is circuit is set to be locked. The phase detector generates the constant DC level, so which is required to shift the output frequency of DC from center frequency. So in phase locked mode, output frequency is reached from the center frequency. So free running mode, the frequency is center frequency. So free running mode to phase lock mode, the output is frequency is reached to F0 output frequency. Here input frequency is equal to output frequency. Once the circuit is locked means, so PLL tracks the frequency changes of the input signal. So after the lock range, so if input frequencies varies means output frequency also varies. So this is called phase lock loop. So important definitions of PLL. So lock range. So it is the range of frequency over which the PLL maintain lock with the incoming signal. So lock range means during the lock mode, so incoming frequency is follows the out frequency is follows the incoming frequency. This is called the tracking range or lock range. Second one is capture range. This is the range of frequencies so over which the PLL can occur lock with an input. So phase lock loop is can occur lock with an input signal is expressed as VCO frequency F0 percentage of VCO frequency. Third one is pull-in time. The pull-in time means the total time taken by the PLL to establish. So total time taken by the PLL to reach the input frequency is equal to output frequency. So this depends on the initial phase and the frequency difference between the signal as well as the overall loop gain and the filter characteristics. So it depends upon initial difference between the phase and the frequency between the signals, overall loop gain, and the overall loop gain, and the loop characteristics. So this is the functional block diagram of monolithic PLL IC565. So this is the pin diagram. So minus V, 1 volt. So minus V is given to pin number 1. So 2, 1, 3 are the input. 2, 1, 3 are the input. 4 is the VCO. 4 is the VCO output. VCO converter is the VCO input. 6 is the reference output. 7 is the demodulated output. So 13 is the NC. 12 is the no connection. 11 is the no connection. 11 is the 13 is the no connection. 11 is the no connection. 10 is the plus V. So pin number 9 is the external capacitor VCO. Pin number 8 is the external resistor for VCO. So from this diagram, so we are giving the input for the terminal 2, 1, 3. This is the input for the phase detector. So pin number 5 is the phase comparator VCO output. 4th pin is the VCO output. This is a square waveform. So this is the VCO block output is 4. So R1 is connected between the R1 is connected between the terminal 8. So C1 is connected to the terminal 9. So 6 is the reference output. Here resistor 3.6 kilo ohm. The capacitor is T2 acts as a low pass filter. So at the pin number 10, we are giving the positive voltage. The pin number 1, we are giving the negative supply. Applications of PLL. Next, we are going to discuss application. So before that, so we are going to calculate the center frequency. So center frequency F0 is equal to 1.2 divided by 4 into R1 into C1 Hz. So R1 is the resistor, C1 is the capacitor connected between the pin number 8 and 9. So generally R1 value lies between 2 kilo ohm and 20 kilo ohm. So capacitance C1 have any standard value. So for this special case R2 we are taking 3.6 kilo ohm. The external capacitor C2 acts as a low pass filter. So applications of PLL. So PLL can be used as a frequency multiplier. So the frequency is multiplied by divided by n networks. Also frequency divider, frequency synthesizer, FM demodulator, frequency shift keying demodulator, AM modulator, and also frequency translators. These are the applications of phase lock loop. So finally, I'm going to conclude this video. A small recap. So phase lock loop means the output frequency and the phase will be locked with the input frequency and the input phase. This is called phase lock loop. So this is frequency control used in satellite communication, airborne navigation system, FM communication system, and computers. This is the basic block diagram of PLL. So we are giving the input to the phase detector. One more input is given by the VCO, that is voltage control oscillator. So phase detector going to compare these two voltage. If any difference will be available, means it produces the error signal. So the error signal is a DC signal. So that is given to the low pass filter. So output of the low pass filter is control voltage or error voltage. So this voltage can be amplified by the error amplifier, and this output is given to the voltage control oscillator. So finally, frequency F0 is generated. So here output voltage is equal to input voltage, that is Fs is equal to F0, means PLL will be in the lock mode. So three different modes of operation are there. One is running mode, free running mode, capture mode, and phase lock mode. Free running mode means control signal is 0. So VCO operated in free running mode. So the frequency is called center frequency. Second one is capture mode. The control voltage process the VCO that predicts the difference between the input signal and the output frequency. So this operation is called capture mode. Phase lock mode means once the frequency is locked, means the circuit set to be locked. So the output follows the input signal. So this is the different definitions. Lock range, the range of frequency over which the PLL maintain a lock with the input signal. So this is the lock range expressed in percentage of VCO frequency F0. Second one is capture range, is defined as the frequency of ranges over which the PLL can acute lock with an input signal. The next one is pull-in time. So it is defined as the total time taken by the PLL to establish the block range. So this is the block diagram. So this is the 14-pin IC. Pin number 2, 3, like I say, input. 4 and 5 is the VCO comparator output. The reference output. 7 is the demodulated output. Number 10 is the positive supply. 1 is the negative supply. So 9 and 8 used to the resistor and the capacitor. So applications of PLL. Frequency multiplier, it acts as a frequency divider, frequency synthesizer, FM demodulated, frequency shift keying demodulated, AM modulated, frequency translator. So thank you for watching this video.